All right, welcome everybody. Good morning. Let's do this. So here we have a question. It states, find all intervals on which f of x, where f of x is increasing. Okay, so we have this function, but notice there's no picture, and you have to find out where the graph is increasing. Yeah. So the idea is, how do we know when this graph is increasing without actually having a visual of it? Okay, so this is what we need to figure out. And just a quick idea, what's the difference between increasing and positive? We'll get to that in a second. But let's imagine, just to warm up, what we want to do is we want to find when this graph is increasing, but we don't have a picture. So what we're going to do first is I'm going to show us the picture of this, and we're going to figure out just from the picture of this graph, when is the graph increasing? Okay, so this is f of x. I drew it really bad. Okay, so the idea is, when is this graph increasing? Notice that what does it mean for the graph to be increasing? When are the tangent lines positive? Okay, so let me write that down. When the tangent lines are positive, or positive slopes. So say when the tangent lines have positive slopes, right? So notice that from negative infinity, right? So we're starting at negative infinity. The tangent lines are positive, 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 stop. Notice that when does it stop? At negative a half. So here, to answer this question, from negative infinity to negative 1/2, the graph is increasing, right? Because the tangent lines are positive. So notice that from negative infinity to negative a half, increasing, positive, 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 stop. Notice what is the slope over here of this tangent line? It's 0. And notice what's happening to the tangent lines from negative a half to 2/3. Notice the tangent lines are negative. So you know the graph is decreasing from here to here. So we don't want that. But then after 2/3, from 2/3 to infinity, the graph has positive tangent lines. So then here we're going to say union 2/3 to infinity. Okie dokie. And that's it. And this is when f of x is increasing. So how on earth can we actually answer this question with no picture? It seems like it's very, very difficult, but it's not that bad. Like, we could do it. So the idea is, the trick to actually doing this is, what are the key things that are really important for us to find? It's these points where the tangent lines are 0. Notice, what do we call these points? We're going to call these, or not what we're going to call it. They are called the critical points. And what are these critical points? You see, this is the graph of f of x. When f prime of x equals 0, that implies that the tangent line for f of x is 0. So when f prime of x is 0, it's at these points at negative a half and at 2/3. So here, when x is equal to negative a half and when x is equal to 2/3, for f prime of x, the tangent line is 0. We want to find these points where the graph changes from positive to negative, or maybe negative to positive. So how do we actually find these critical points? And that's the idea here. What we want to do is, we want to take f prime of x and make it equal to 0. Okay? So first what we're going to do is, let's have this function here. So if we know that this is f of x, what I'd like you to do is, and we all know how to do this, what is f prime of x? Okay, well, take the derivative of the function, right? So let me actually zoom in the camera a little bit better. Okie dokie. So here, what is the derivative? We all know how to do this. This is 12x squared minus 2x minus 4. Okay? that should be no problem, right? Now, what are we going to do? We're going to take this function of 12x squared minus 2x minus 4, and we're going to make it equal to 0. Okay? Now, the idea from here is, what can we do? Here, if I said, hey, let's look at this function, what does x equal, question mark, how do we actually do it? And this idea is we have to go back in time a little bit. We got to do some factoring. What I'd like you to do is try and factor this all the way without my help, right? So what's the first move in factoring? Is there a GCF, right? GCF question mark. Yeah, there is. It's 2. So notice it's 2 times 6x squared minus x minus 2, okay, equals 0. Now the idea is, can you factor this? And you can, and you have to use AC method. And some of you are like, oh man, mister, it's been a minute. Okay, so what I'd like you to do is try and use the AC method to actually factor this. And what do we get? We have, let's see, so how do we factor this? What do we say? We say a times c, right? 6 times negative 2 is negative 12. What two numbers, when you multiply, give you negative 12, but when you add, give you negative 1? Pause the video and try and figure that out. I'll say it again. What two numbers, when you multiply, give you negative 12, but when you add, give you negative 1? It should be negative 4 and positive 3. Because here, what is negative 4 times 3? It's negative 12. What's negative 4 plus 3? It's negative 1. So then what do we do with that negative 4 and 3? So notice that we have 6x squared minus x minus 2 equals 0. Now we're going to have, now we're going to have 6x squared minus 4x plus 3x minus 2 equals 0. Then once we get to this point, what do? We have to do factor by grouping. Okay? I know this has been a while, so don't feel discouraged, but we all know how to do this, right? I know it's been a while, right? But here, how do we do factor by grouping? What do we do? Group, 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 group. Okay, so now let's take the GCF of this group. It should be 2x times 3x minus 2. Oh, and notice, look what we did. You remember, we want two of the same things. What's the GCF of this group? At 1 times 3x minus 2 equals 0. Okay, let me actually get rid of this. I'm sorry. So now what do we have? We have 2x plus 1 and 3x minus 2 equals 0, right? Because here, these two come over here, and these two are common. We have a common binomial, so we're here. Now, once we get to this point, what do we say? We say 2x plus 1 equals 0, and then 3x minus 2 equals 0. And now here, how do we get x by itself? You say 2x is equal to minus 1, so x equals negative a half, right? That's one of them. And here you have 3x, add positive 2 on both sides, 3x equals 2, x is equal to 3 over 2. I'm sorry, not 3 over 2, 2 over 3. Let me rewrite that. X equals 2 over 3. Now, what was the purpose of doing this? Because don't you remember from this graph, what's so important about x equals negative a half and x equals 2/3? Don't you remember from the graph over here? Let me zoom out. Notice what's happening at negative a half and at 2/3. The tangent line is 0. So what's happening here is, let's say if you don't have the graph and you just have these two numbers. So what you can say is, you're saying, okay, I know at negative a half and at 2/3, something is happening. You don't know, like right now, let's say if we don't have the picture and we just have this information, the graph is either going to go positive, 0, negative, or the graph could go negative, 0, positive, right? So the idea is, whatever is left of negative a half, Like, let's say if we have some fields here, right? You know, left of negative a half, the graph is going to be positive or negative. You don't know if the graph is going to be like this or it's coming in like this. Okay? And that's the idea. Right now, we know the graph is like this, but you don't know. You just know that it's either negative or positive. So the question is, how do you know without actually looking at a graph which side it is? And the idea is, all you need to do is plug in a number left of negative a half. For example, if we know that the graph is positive, right? If I plug in a number left of negative a half, I'm going to get a positive number. So let's see why that works. So let's pick any number left of negative a half. Let's say we pick x equals negative 1. If I plug in f prime of negative 1, that means I'm plugging in negative 1 into the derivative. I'm sorry, I messed up the camera angle. If I plug in negative 1 into this derivative, it should give me a value, positive or negative, right? So the idea is, let's see, what is f prime of negative 1? So you know that f prime of x, let me actually organize the information. Okay. We know that f prime of x is equal to 12x squared minus 2x minus 4. So now here, what we want to do is, let's plug in f prime of negative 1. And what's the reason why we're plugging in negative 1? Because we want to test to see if the tangent lines are positive or negative left of negative a half. Okay? So let's see, if we plug in negative 1, what do you get? 12 times negative 1 squared minus 2 times negative 1 minus 4. Now, I don't care what the value is. All I care is it positive or negative? Okay? So let's see, this is what? 12 times, this becomes 12 times 1 minus, this should be a plus 2 minus 4, right? So notice, I'm sorry. It's not that you don't care if it's positive. I'm sorry. What you want to do is you want to see if this number is positive or negative, okay? So let's see, 12 times 1 is 12, plus 2 minus 4, this is 14 minus 4, you get 10. Notice that this value of 10 is a positive number. Because this value of 10 is positive, you know that the graph has to be positive coming from the left of negative a half. Because if one of these values is positive, the rest have to be positive. Because you're either positive, negative, or 0. Okay? And we already know where the zeros are. The zeros are at negative a half and 2/3. So you know that if one side is if one of these values is positive, the rest are also going to be positive because there's no other 0 to the left of negative a half because we already found them. They're only negative a half and 2/3. So notice that to the left of negative a half is positive. So what can I say? I could say that from negative infinity to negative a half, the graph has to be increasing. So increasing from negative a half to negative infinity. Now the next question we have to ask is, what about between negative a half and 2/3? Is the graph increasing or decreasing? And all we need to do is plug in any x value between negative a half and 2/3 to see if it's increasing or decreasing. What would be the best number to plug in? The best number to plug in is 0, because that will just make your life very easy. So let's plug in 0 to f prime of x. If f prime of x is equal to 12x squared minus 2x minus 4, and we plug in f prime of 0, then you just get, this is what, 0 minus 4, you're going to get negative 4. Notice that because I have a negative value, that you know that the graph is going to be decreasing between negative a half and 2/3, and the graph is, if we look at the graph, you see how the graph is increasing from here to here. It's decreasing from negative a half to 2/3, and then it's going to increase past 2/3. But how do we actually do it if we did not have this picture? We have to plug in a value to the right of 2/3. What is a value? What is a good value to the right of 2/3? Plug in 1. 1 is a nice easy number. So what is f prime of 1? Well, then this just becomes 12 minus 2 minus 4. 12 minus 2 minus 4 is 12 minus 6. Notice that we get a value of 6, and this number is positive. So then we know, because to the right of 2/3, that this value has to be, the graph has to be increasing from 2/3 to infinity. Whew. Okie dokie. That is for increasing and decreasing. What I'm going to do is, there are two other questions that we need to actually solve. It's the relative maximas and relative minimas. What I'll do is, I'll make a second video on how to complete this, which actually, you know, it's not even too bad, because we could do it right here. Actually, you know what? Let's just do it right now. It'll be very short. Where in this graph, going back to this example, right, of f of x, here, where are the relative max? So let me get a good color. So here, where is the relative max and where is the relative minimum? Here, if you look at this graph, once you know when the graph is increasing, decreasing and increasing, notice a relative max is happening here, because if you look at it, the cusp is like this. And notice, how do we get a relative max? You have to go from positive, 0, negative, right? The tangent lines are positive, then it becomes 0, and then it becomes negative. So if you know that the graph is increasing, right? Let me fix a camera angle. You know that the graph is increasing from negative infinity to negative a half, right? Then you know something happens at a half, right? You know after negative a half, it starts decreasing. The second you have the second you have the tangent lines from positive to negative, then there has to be a relative max. So we know our relative max is at x equals negative a half. What about the relative min? Here, the relative min is at x equals 2/3, because the tangent lines are going from decreasing to 0 to increasing. Okay? So let's try and maybe answer this question over here. Here, don't freak out, but it's saying find the x coordinates of the relative maxima. So the idea is, first, we want the critical points. Okay? Now notice, we don't have a picture of this, and I'm not going to show you what the picture is. If you want to see what the picture looks like, you could always go to Desmos and plug in the function and take a look at it. But for now, I mean, you could do that when you first start it, but once you get better with these questions, I want you to try and do it without looking at Desmos. But let's try and actually solve this problem. First, you want the critical points for f prime of x equals 0. You want to know, when are the tangent lines for this graph, when is it 0? So here, what are we going to do? Let's first find f prime of x, and that's equal to, okay, so this, we got to actually figure this one out. This becomes what? What is 5 times negative 3/5? It just becomes negative 3x to the 4th minus 36x cubed minus 105x squared, and yeah. Now, how do we get to this point over here? Now you know that f prime of x is equal to negative 3x to the 4th minus 36x cubed minus 105x squared. Now, I found a difficult problem for us to do, so be patient with it, right? Now, what do we need to do? We need to take this negative 3x to the fourth minus 36x cubed minus 105x squared, and we're going to make it equal to 0. Let's look at our notes for how we solved the last problem, right? What did we do first? First, we made the function equal to 0. Then, what's the idea? Is there a greatest common factor? Is there a greatest common factor here? And remember, we have a negative leading coefficient, so what is the GCF? It should be negative 3x cubed is the GCF. Because, yeah. Oh, no. Negative 3x squared, sorry. Okay, so if we factor out our negative 3x squared, we get x squared plus 12x plus 35 equals 0. Now that took me a second to figure that out, but because notice, what do you have to do? You have to divide each of these by negative 3x squared, okay? And that's what you'll get. Now, once you get to this point, you have negative 3x squared. Now, this one's easy to factor. What two numbers, when you multiply, give you 35, or when you add, give you 12? This should be x plus 7, x plus 5 equals 0. Now, what can we say? Here, in the previous problem, if you looked here, what was the GCF? It was 2. And notice, I didn't have to do anything with the 2. I wasn't going to say, like, you saw how when I factored this, we got this, and we made this equal to 0, and this one equal to 0. But technically, there's also a 2 equals 0, but that makes no sense. Here, we're going to have to say that negative 3x squared equals 0, x plus 7 equals 0, x plus 5 equals 0. Okay? Now here you say x is equal to 0, x is equal to negative 7, and x is equal to negative 5. Okay? Now, what does this mean? That means that if I have the graph that we know at 0, at negative 5, and at negative 7, these are the critical points. You don't know if the graph is increased, like here, we don't know what's happening to the left of negative 7. You don't know what's happening between negative 7 and negative 5. You don't know what's happening between negative 5 and 0. And you don't know what's happening to the right of 0. But the question is, like, how do we actually figure out what's happening? All we need to do is plug in a number. So let's plug in, let's say, negative 8. Right? Let's plug in negative 8. What's a number between negative 7 and negative 5? Let's plug in negative 6. Let's plug in, I don't know, negative 2. And a good number here would be 1. Okay? So what you need to do is you need to plug in a number to the left of each one of these. I'm sorry, something to the left of negative 7, something in between negative 7 and negative 5, something between negative 5 and 0, and something between 0 and positive infinity. And we have to see what value we're going to get. Is it going to be positive or negative? Okay? So here, I feel like we're going into overtime. My bad. I did not mean to make such a long video, but this is AP Calculus, right? So here, what happens when you plug in negative 8 into f of x? Well, what is f prime of x? F prime of x is negative 3x to the fourth minus 36x cubed minus 105x squared. So with the calculator, you could plug in negative 8, and that's exactly what I'm going to do. Hold on. Where is my calculator? Oh, yeah. Let me get it real quick. Okay. Oh, wow. It's so dusty right now. I haven't used this in a while. Okay. Let's plug in negative 8 and see what do we get. So here, let's see. So we want to plug in negative 8 into this. So here we have negative 3 parentheses, negative 8, close. Wait, let me type that again. Negative 3 parentheses, negative 8 to the 4th minus, this is so boring, 36 parentheses negative 8 cube minus 105 parentheses negative 8 squared. Boom. Notice that whatever, I don't care what the number is, I care if it's positive or negative. So notice that this is negative. And what does that mean? If you were to put this into Desmos, you know that the graph has to be coming in like this for negative 8. I'm sorry, left of negative 7, because, hold on, left of negative 7, the graph has to be something like this. Okay? And you know that the tangent lines are negative because when we plugged in a number left of negative 7, we got a negative value. So now we have to do the same thing for negative 7 and negative 5. The graph from here could go up or it could go down. And you know it's not going to be 0 because the only places where the tangent line is 0 is at these 3 places. So you need to test the number. Let's test negative 6. Actually, the best way to, there's a faster way to do this, but for now I'll just do it like this. So let's plug in negative 6. So negative 3 parentheses negative 6 parentheses to the 4th minus 36 parentheses negative 6 cube minus 105 parentheses negative 6, the whole thing squared. And now we got positive 108. So what does this mean? That this graph right now has to go something like this. Okay? I mean, it could be anywhere. It could be above the x-axis, below the x-axis. But all I know is that this is negative to positive. Now we got to do the same thing for what? Negative. We don't have to use negative 2. We could actually use negative 1. That would be better. But let's try negative 1, right? Because negative 1 is between negative 5 and 0. So this is negative 3 parentheses negative 1 close to the 4th minus 36 close open negative 1 close to the 3 negative 105 x, I'm sorry, not x squared. Did I plug everything right? Yeah, it looks like it. Okay, enter. Notice that this is negative. So now I know that the graph is going to go something like this. So it goes from negative to positive to negative. Now don't just think it's always going to be negative, like it's not, it doesn't always change. Like it could be negative negative or positive positive. You never know. Because like the graph like is negative, but then the graph could just like dip again down. You don't know, so you have to check. Now let's check in 1. So now let's plug in 1. So negative 3, 1 to the 4th minus 36. Oops, sorry. Let's try that again. Negative 3 parentheses 1 close to the 4th minus 36 open 1 to the 3rd minus 105 1 squared. And notice that this is negative as well. So here this goes down like this. And did I plug everything right? Yeah, I did. Okay, so this is negative. Now going back to the question is asking where has to be a relative max. You know a relative max occurs when the graph goes from positive to negative. You see, this is where the relative max is. So you're going to say that the relative max is at x equals negative 5. And that's it. Well, not that that's it, but that's how you solve it, because you found that It had one relative max. What about where is the relative min? The relative min is at x equals -7 because it goes from negative to positive. Like when you have a negative to positive, you have this cusp of a min. This cusp is a max. Okay, I wish you the best of luck. Try the delta math. Do not give up. Okay, you can do this. Wow, 30 minutes. I cannot believe I made a 30-minute video. I'm sorry, I didn't mean to make it this long. I'll see you soon.